Okay, we're live. Hi, this is Toby. I thought I would I thought that I would make a programming language from scratch on the stream because in my how to make a programming language series, um, which if you don't know about that one, you can find it on my website, um, tobyho.com. Uh, it, oops, it's this one. Oops. Okay, this one down here. Um, so in this series, I sort of talk about first at a high level, what is it like to make a programming language, and then I go to the more low level, how to actually do it. In particular, I teach how to use a parser generator tool called Nearly.js to make a parser. There's a big part of the series is how to use that tool to build your own parser. Um, but then after that, it goes into how to build a code generator, how to deal with ASTs, etc. Although that part of it is not quite as fleshed out. Um, but throughout the series, I have never actually built a sort of complete programming language. I dealt with smaller examples such as how to make a JSON parser, how to make a parser for simple arithmetic, like arithmetic expressions like 1 plus 1 times 2 and stuff like that. Um, so I would like to change that. I would like to give an example of what it is like to build an actual full-fledged programming language, starting with this stream. So let's get started. Let me check the stream condition. Currently, it says excellent condition, and that's cool. Okay, I am going to do this. So what's the programming language I'm gonna be building? I just called it X because I couldn't think of a good name for it. This is off the cuff, and I came up with this sort of syntax. I wanted the syntax to be conventional enough, but also somewhat different from what you're used to. So it looks very much like a Python or a Ruby in the simplest cases of when you're just assigning a variable, declaring a variable, and doing simple arithmetic. But it deviates in some places, and in one particular thing that I sort of feel strongly about is in order to improve to remove visual noise of the language. Remove visual noise. I'm gonna sort of remove the characters that are, as in ASCII characters, that are noisy. And one of those that I really hate is the curly bracket. So curly brackets are out. So you can see whenever like a conventional language would use a curly bracket, I'm gonna use a square bracket. Another thing, and these arrows, I might change them to be colons to be more conventional because I feel like the arrows are also, there's more visual noise there. I also decided to remove these commas. So maybe another rule is commas are out, and also semicolons are out. I don't like these. I think they have more visual noise because there's like very fine detail in this little in the what should it call it? The embellishment of the character has fine details in it, and I think that's like too much visual noise. This is my opinion. You can totally completely disagree with that. Um, and I thought of I thought this is how you would do classes. This is how you would define functions. When you're calling a function with multiple parameters, you don't even separate them with commas. And the blocks again use the square brackets instead of the curly brackets. So that's what I thought the language would look like. Let's get started on building this thing. I thought maybe for the first stream I would do something simple, so I could make variable assignments work. I could make function calls work, and for the first draft of this, the function call will just support the print function and nothing else. And if we have time, it will do something more, maybe the if statement or the while loop. These are some features I wrote down that can definitely be revised. Okay, so that's the idea. Let's get into it. Let's see how much we get done. So actually I'm gonna try to use this stickies on the Mac, and in particular I heard from Professor Mark Gustile that sub-goal labeling is a very useful tool for learning. So I'm gonna try to do that. So right now, what I'm gonna start with is I'm gonna set up the project. So project setup. Maybe like step 1 is project setup, which means npm init and install dependencies. Okay, so we're doing project setup right now. Let's go ahead and do that. So I've already created this xlang folder here, and currently it has these two files. This example I kind of sketched out, and a feature list that I sketched out. I'm gonna do npm init. Let me make this font bigger so you can see a little bit better. Oops, not npm ls, npm init, and with the -y flag, which will skip the questionnaire. Okay, so this is my npm, and the one dependency I want is the nearly JS package. Oh, npm install nearly JS. I think I want this to always be on top. How do I do that? I made this one almost on top, always on top. Well, no, I don't want to delete this note. How do I make this always be on top? Bring all, there's another one. I'm gonna delete this one. Excuse me while I figure out the stickies. Float on top. Okay, so is this floating? Okay, this sticky is floating on top. Great, that's what I want. Okay, so I said nom init. I meant npm init, sorry. Okay, and perhaps I can make this text bigger too. Okay, I think that's pretty good. Okay, so I've actually done project setup now. And now the first thing I'm gonna do is build a simple parser just to get me going. So and I think what I might do is, oh, there's a choice actually. Do I want to build the Lexer first and then build the parser? Because I did cover using a Lexer, which is moo.js. Let's do that. I'm gonna install moo.js as well. We're still in the project setup, so we've installed moo.js and nearly JS. Now the next step is, how about let's build a Lexer. Build a Lexer using moo.js. So that's gonna be our second step. Build Lexer using moo. Okay. All right. So how do we build a Lexer? I'm gonna make a Lexer file. It's going to use moo. Okay, so I'm gonna go back to the moo.js website to get a basic example of how it works. Okay, so the basic example is you first make this call to this compile function with this specs, and each spec or you could call each one of these guys a matcher perhaps, has this regular expression in it, or most of them do. Some of them have these array of choices. So and this matcher, basically, whether it's a regular expression or an array of string literals, would be used to parse the text and then generate tokens. If this guy matches, it's gonna generate a WS token and so forth. So let's do that. So in my language, we have these guys, which are identifiers. So the tokens, I'm gonna draw out the tokens that we might have in our language. Give me 1 second too. I'm gonna try to log into my phone, or log into this stream using my phone. So in my language, we have, okay, that's myself talking. Okay. I'm gonna say hello. Okay, that's in case anybody logs into the stream and asks questions, I can answer. Okay, so what I'm gonna do is say, so sort of draw out what the different kinds of tokens are in this language. So one kind of token would be these, which are variable names, or function names for that matter. So this is a function name, this is a function name, and this is a variable name, for example. These guys I'm gonna call, and there's more of them. I'm not gonna draw out every single one, but I'll draw out some more actually. Perhaps I should draw out every single one. I don't know. So these guys here, all of them, they're called identifiers. Typically in programming languages speak, they're called identifiers. They identify actual things that are in your program. So they're called identifiers, and they can either be variables or functions. So that's one kind of token. Another kind of token is this. That's just the assignment operator, perhaps. Yeah, or I could call it the equal sign. Although calling it the equal sign is kind of a misnomer. I'm gonna call it the assignment operator. So let me write that down actually while I'm doing this, so that I don't forget. Okay, so I'm in a comment. So I'm gonna need identifiers. I'm gonna need assignment operator. I'm going to need these parentheses. So this left paren and the right paren here. This is, I'm gonna call this the left paren, and this is the right paren. Left paren and right paren. And then we're gonna have the plus and the plus minus times divide. For now, we'll just deal with simple arithmetic. So these are the arithmetic operators. What else? So there's white space, obviously. White space. Perhaps I just call it WS. So this is white space. this is white space, etc. This is white space. There's left bracket. I'll call it left bracket and right bracket. So this is a left bracket and this is a right bracket. I think this, I'm gonna switch it back to the colon maybe. What do you think? So for dictionaries, entries look like this. And perhaps we use the white space to be like I don't even want to have commas in this language. So the entries are just separated by white space. You could optionally put white space in here too. But if you do that, you probably want even more white space in between the entries, so that otherwise this might look a little confusing, I guess. That's sort of an aesthetic choice though that the programmer is gonna make. So that is a dictionary. So I'm gonna say colon is another one. What else? The if keyword, if else, if keyword, else keyword, and for keyword. These are keywords. Oh, and the in keyword as well. And I suppose this new, that doesn't actually have to be a keyword, but there's a class keyword. I don't know. Maybe the new is a keyword, but I'm not totally sure. Or new could just be a special identifier too. It doesn't necessarily have. Oh, for strings, we're gonna have this quote here. So double quote. And are those all the tokens that we're gonna need? Probably. That's probably all the tokens that we have, at least in this example. So I'm gonna write a Lexer based on this. Okay. See if it works. Move that compile. Okay, I'm gonna move this back in the center of the screen. So the white space thing, there's actually a difference. We might need to differentiate between a new line and a white space. So let's say new line is also a let's say new line is also a token, which is different from white space. Okay, let's see how that goes. And we might even be lazy here and not implement all of these tokens for now, and only implement enough of them so that we get the objectives done. And I would say today's key objectives are getting variable assignments going and getting print statements going, and maybe if statements too. Not sure. I'm not sure if I want to do the arithmetic thing yet, because I've covered that in another video, and I feel like, I won't maybe just do something different for this go. Okay. So I'm gonna make sure I do identifiers and the assignment operator and number. Oh, I forgot about numbers. Number literals. Oh, I would say string literals actually. String instead of the quote. Yeah. Instead of modeling the double quote, I'm just gonna have the Lexer figure out the string literals and the number literals, and let that be that. Yeah, that's how I usually do it, and that's how it's usually done. Okay, so I'm gonna need to figure out number literals and string literals. I think I can probably just steal these steal this example from Moo.js because these guys are so common. So I have my number literal and string literal. This string literal, I guess it's saying it matches a double quote. Let me make this text a little bigger. It's gonna match a double quote and then this question mark and then colon. That I believe that is just saying I'm not trying to capture whatever is in it. So that's kind of inconsequential here to what it's actually trying to match. And then this is saying, what is it actually saying? Doubles. Oh, this is a slash. This is escape, and then it wants to escape the slash. So this is a literal slash here. This is a literal slash. So if there's a slash, because the user wanted to escape something, and they can escape either a double quote or they can escape a slash in their program. Got it. Or if it's not a what? Or if it's not a new line or a double quote or this is any character, anything that is not a new line, a double quote, or a literal slash, and you need two slashes to mean a literal slash. So it's between the double quotes you can have anything that's not one of those guys, or that's the or, so that means or you can have a double slash and then a double quote and a slash. So you can escape a double quote and escape a slash, basically. So that's what a string is. That's good enough for me. And then for number, what's a number? It's either a 0 or first you have a non-zero digit and then any number of 0 above digits. That's a number. This doesn't account for decimal numbers, but I actually don't care for now. So this is fine. This definition for number and strings is fine, and I'm probably gonna copy his white space definition. That's just any space or tab. That's a white space. I'm gonna lowercase it. And then do I care about parens? Yes, I do care about parens. So I'm gonna steal his left paren and right paren as well, because I need the same thing. And then I need an assignment operator. So assignment operator. He doesn't have that. I'm wondering whether I should use the underscore convention or a different convention, or like camel case convention. Left, or I could spell this all out: left paren and right paren. Although it may not even matter practically speaking, because I'll just use the underscore convention. So assignment operator is an equal sign. And what else do I need? I got numbers, I got strings, so I should be able to match that. Identifiers, do I have identifiers? No. And he doesn't have identifiers either, so I'm gonna have to make that myself. So what's an identifier? Identifier is it's any number of in JavaScript you start with a alphabet letter and then it's followed by alphanumeric letters, plus the underscore or the $sign. I'm not gonna allow the $sign because I think it's weird. I'm going to excuse me. Excuse me. Okay, so I'm gonna say it's starts with an alpha, followed by alphanumeric, I'll throw underscore in there. Okay. So yeah, more or less like JavaScript, except you can't do $signs. And this and this, for those of you new to regex, this star means 0 or more repetition. 0 or more of the preceding thing, which is that. So 0 or more of that, which is a character class that includes this range, and this range, plus that underscore here. So I think that's good enough for what I want. So far I have done white spaces, number literals, strings, left paren and right paren. Right. Oh, I'm gonna need new lines. I'm just gonna steal his new line. So in Moo, you have to configure if there's a token. If there's a token that can take line breaks, you have to set line break to true. So I'm gonna call this new line. I'm actually gonna spell out white space because there isn't actually. I don't think it'll end up making my code verbose to call it white space here, because I'm probably just gonna give it an alias once I get into the nearly grammar. Alright, so I'm gonna do it like this. So far I have left paren, white space, number, string, left paren, right paren, assignment operator, identifier, and new line. So I have these things. The rest of them I haven't done yet. So I'll grab these and I'll say to be done here. These are the things that are not done, or maybe I say not done. So these are not done yet, but now what I can do is perhaps I do a module that exports equals this Lexer, and now I can or maybe even simplify it to no, this is okay, maybe I could just do this. I'm just gonna export this, and then I make another script that would use this. So let's make test Lexer. Let's make a script called text Lexer, and we have this example. Let's have a smaller example. Example 1. I'll call this maybe example 4. Okay, so I'm gonna just go with example 1, which I'm gonna have it basically test out all the features we have so far. I'm gonna split right. Okay, so I want to have white space, which it has some white space here. Maybe at 1 or 2 here, and N and M and M. Okay. M and O. Maybe O is a string. Our strings always have are delimited and closed in double quotes always. Okay, so I'm gonna print out N, M, and O. We have identifiers because that's what N, M, and O are, and print. We have left paren and right paren here. I'll print again. I don't know. Maybe I'll separate them. Oh, it's also possible to just print a number. Okay, and print a string like that. And yeah, I think all of these token types have been represented. So I'm gonna write a test script to read in this file and ask the Lexer to lex it, if it were. So I'm gonna do gonna use the promises version of the FS API. I like doing async await, so I'll stick to that. Okay. I'll say read in example 1. Okay, I'll print this out first. See that worked. Test Lexer. Okay, that's a buffer. I want to convert it into a string. You do it like this. Call the toString method. Okay, there's the code. So there's the code. I'm gonna now require the Lexer. Okay. And have the Lexer. How do you do it with the Lexer? I have to call Lexer.reset of the code. That just feeds the input into it, and then you call next. So while true, I'll make a token variable. While true, token equals Lexer.next. If token else break. You might be wondering why I didn't write while token equals that. I could write it like that too. For some reason I've been liking the while true pattern. I'm probably a minority in that opinion, but that's okay. Okay, so I'm gonna try to write this, run this code. And those are our tokens, and everything seemed to work fine. Let me think. We get the text. So perhaps to get this to look a little more clean or shorter, I'm gonna just print out the type of the token. So a token has a type, I believe. Yeah, has a type and a value. And I just print the type and the value. So, and I guess I'm gonna JSONify it, the value. so that the new line doesn't actually become a new line. So I have an identifier. Let's do it side by side with my program. So, oops. Okay, there. So these are the tokens, and I hate that there's this warning message when I use the promises version of the API. Whatever, ignore that. Okay, so given this program, these are our tokens. First, we have an identifier whose name is n, and then we have a white space, and then we have an assignment operator, and then we have another white space, and then we have the number 4. With the number, we might decide to convert this guy to a number, which we can do. Let's go ahead and do that, like actually convert it to a number. And Moo.js allows us a configuration option to do that, actually. Let us find it. What is it called? It's called the value. So if you provide a value transformer, then it'll call your value transformer to convert the string, the text, to a something that might not be a text. In order to do that, you have to wrap this bad boy in an object first and call the matcher match, and then you can supply a value. And then for my value, I'm gonna just use the number function, because number function is a function which, if you call it with a numeric string, it'll give you the corresponding number. So I'm not even gonna write an arrow function or something like that. I'm just gonna plug in the number function and run this again. And now I should have, for numbers, hello, where's my number? Oh, there, I got it. Number is 4, and this is not double quoted, so that's a good indication to me that it's an actual number. Okay, and I could go through a bit more, verify everything is correct, but it looks pretty good to me right now, so I'm not gonna dwell too much on it. So now we have a Lexer. I have Lexer, so we've completed this step, build Lexer using Moo. Although we haven't completed all the features, I'm gonna save some of the feature for the some of these features for the future. So we have to come back later and revisit the Lexer at some point. But now I think we're ready to start writing a grammar to try to turn the stream of tokens into an AST, which stands for Abstract Syntax Tree. Okay. How do we do that? I'm gonna make a file. Let's call this guy grammar, or maybe parser.ne or grammar. I'm gonna call it grammar.ne. Ne is the file extension for nearly. Okay. And I'm gonna look up how to plug in a Lexer into nearly again, because I don't have it memorized. So I can look at the tokenizers section. Okay, so this is how you do it. You make a block that starts with @ open curly bracket and %. And then you do what you need to get your Lexer in the scope, and then later you do @Lexer and then put the identifier of the Lexer after this statement here. So this is the key one. The fact that he did this Moo compile in here and I decided to do it in a Lexer.js, that doesn't matter. I'm just gonna require Lexer.js instead of Moo here. Okay, so in this grammar, so here I'm gonna update my step. I'm gonna make a grammar in nearly. Okay, I'm gonna make a grammar in nearly. Okay, so it looks like at sign and then open curly and then percent sign and then percent sign close curly to stop that block. So this is a block that allows you. Oh, hi. I have ISAT. ISAT is here. I'm gonna say hello to him. Why he can hear me? Why am I typing? Okay. I'm not used to this. So now I'm going to require my Lexer. Okay. Which I have already declared in my Lexer.js. So I'm just gonna import it or require it in this way. So that's gonna get whatever I assign as the module exports here is that guy. That guy gets required and it goes into my Lexer const over here. And then after that, I have to still tell it that this Lexer is the Lexer I want to use, because I could have named this to like my Lexer and then use this name over here. Okay, I'll leave it like that. I'll call it my Lexer. Okay. So now with the Lexer plugged in, I should be ready to write my grammar. So the first element I want to write, I think, is just maybe the assignment. Okay. Maybe, or maybe I could write. Let me just write the assignment first. So assignment. What is an assignment? Assignment is gonna be an identifier. Identifier, and in nearly the percent sign is how you identify a token by its type name. Okay, so if you want to identify it by this is the type name. The percent sign is how you do it. If you want to identify a token by its string literal, you can actually just write the string literal. But identifier is this dynamic thing that you could potentially have any name in the identifier, so it makes more sense to identify it by the type name. Whereas if it were something like a left paren, well, the left paren, you could write this to identify the left paren, but it's actually more convenient to just write the string literal for the left paren, because the string literal for left paren is always going to be the left paren. So those are the choices you have when you're working with the Moo.js tokens in Nearly.js. Actually, you don't necessarily have to use Moo.js to make the tokens. You could potentially handwrite your own Lexer if you want to. Okay, so I'm going to say an assignment is an identifier and then an assignment op. But an assignment op is, I know it's always going to look like an equal sign. So I'm going to just write it like that. And then after assignment, we'll have a literal value, which can either be a number literal or a string literal. I'm going to actually make another symbol for literal, okay? So I'm going to say literal, and then I define what literal means. Literal is, I'll do another line here. A literal is either a number or it's a string. Okay, so that says assignment is first an identifier, then this equal sign, and then a literal. And what it's a literal is either a number or a string. And I guess that would work for assignment, but we haven't done the white space. So I'm gonna start with a simple. Oh, this is another project I had. I'm gonna close that out. I'm gonna start simple. So maybe like I'm gonna make maybe like just play example. I have this example 1. Maybe I'll make another example, call it example just assignment. just dealing with assignment, like n equals 4. I'm gonna do the white spaces later, okay? Not just now. Okay. So I need to compile this grammar first, and then I need to actually write a script to drive this grammar. So let me compile it. To compile it, you do npx nearly c, the name of the grammar file, and then tell it what the output file should be. In this case, I'm just gonna output it to grammar.js, and it should have generated grammar.js. It did. So I'm gonna copy this command. You don't have to copy the npx part when you copy it. I'm gonna make that one of the scripts. I'm gonna call this gen parser. That way it's more convenient. I don't have to type this out or remember this, so I can do npm run gen parser, and it'll regenerate the parser for me. But once I have generated the parser, or generated the grammar, perhaps I should say, I still need to do this, write a script to take this grammar file and make a parser out of it. So let's do that. And I don't have that memorized either, so I'm just gonna go back to this getting started example and use that. I'm gonna make a new file called parse. Okay. And I did call my grammar.js, so this totally works for me. And I'm gonna then feed something into it, and then whatever the parser got as its result, that's the result. Since I made this example assignment x, I might as well use it. So, and perhaps I will even have pass in as a parameter to parse what the file is I want to parse. Okay, so again, I'm gonna use the async await, because that's how I like to do stuff in Node.js. Okay, I'm gonna do it like this, and then I'm gonna get the file name from process.argv2. Why 2? Because when you write node parse.js, and then the name of the file, example assignment.x. This is arg0, this is arg1, and this is arg2. That's why we need to get arg2. So we want to get the file name as arg2. That's why. And then we're gonna say if they didn't provide the file name, then we're gonna write an error message and say please provide a file name, and then just return. If they don't provide a file name, we're not going to do anything. And then we're going to read in the file, await fs.read file, the file name toString, as you remember. And again, we're going to use the promises version of the file system. Here's the code now, and the code is what we're going to feed into the parser. And after the parser is fed some code, it's going to have some results, and we're going to print that out. So let's see what happens. So we're going to node parse example assignment x. It said please provide a file name. Oh, if not file name. If they did not provide a file name, then do that. Okay. So, okay, I think that means it worked. Kinda. It got, because if it didn't work, then we should have gotten an error. Like, let's say we made a syntax mistake, like, I don't know, it didn't have a for. Then it would, because at this point this is actually still not an error because it hasn't gotten to the point of, like, this is, if it received more input, it could still be correct. But if I gave it something that it doesn't know, then now it definitely, that's actually a Lexer error. Okay, but in any case, this means it worked. If it printed out something, that means it has made a full parse. But that's not good enough because we want it to be translated into an AST that's easy to consume. And usually the way I construct ASTs is I just follow the example of the JavaScript parsers, where each AST node is represented as an object that has a type. So if this one is called an assignment, then the type might be called an assignment or an assignment statement. And then it can have additional stuff like the identifier that you're assigning to. I call that var name usually, or we could call it identifier if you want. And then this is maybe an identifier node and so forth. And then it would have a left hand side, like we're assigning the value. And so this has the var name of n, and the value has the actual number in it that has the value of 4, and so forth. So that's what we're gonna build. But before that, let's allow white spaces, because currently this white spaces doesn't work. Yeah, white spaces doesn't work. I just wanted to prove that point, and I'm gonna modify the grammar to allow the white spaces to work. Nearly sort of recommends this this convention of using underscores to mean optional white space. I'm gonna follow that. So I'm gonna say underscore is a white space, okay? And this is the white space token that is supported by our Lexer here. Oh, I actually spelled it all the way out like that. Okay, so underscores mean white space now. Okay, so now it should support white spaces being in there. Oh, I need to regenerate the parser. Okay, did that. Run it, and now it works. Now it supports white space. But this output is still kind of hard to read, so I want to rectify that. So how do we do that? The first thing is for any rule where the right hand side only has one symbol in it, such as this one and this one. So the right hand side only has number in it in this case and string in it in this case. I'm gonna use this ID function, which says just unpack the thing in there, because otherwise it's gonna give you an array with just that thing in it. So just unpack that array so we don't get the extra array. So if we did that, I need to run gen parser again. If we did that, then we actually get that number unboxed, and we can see it now, and we get that identifier unboxed. But the unboxing, we also want to do that here. So here I'm gonna write a little transformer and say and then give it a function. This ID is like a pre-packaged or out of the box function you can use, but you can write your own functions. And I've covered this before in other videos, so I'm not gonna get too detailed into how it works. But basically, these guys, these symbols, each one matches some string, and each match is put into this array. So it ends up looking like an array like that. And this array is gonna have 5 elements in it, right? So that array is gonna be fed in as the parameter of that function, and we're gonna call this array data. Data is gonna have 5 elements in it. I'm only gonna pick out the ones that I care about, which is identifier and the literal. Okay, so I'm gonna return an object to represent what an assignment is. An assignment is an object that has the type of assignment and its name, maybe var name, variable maybe. The variable is var name. I'll call it var name. Is the 0th element of this array. See, this is the 0th element of the array, and this is the last one, which will have index 4. And the value is index 4 is the literal. Okay, so if we did this, we'll end up with an object that looks like this. At the end, we'll regenerate the parser, run the script again, and now indeed we have an object that has a var name, which is an identifier, and a value, which is a number token. And these tokens actually have offsets and line numbers and column numbers, which this is will be helpful information for error reporting. So if you find an error, you want to report the error to the programmer, you can do that. Okay, and then why is this an array though? Okay, why is this an array? It's because sometimes your grammar can be ambiguous. It could be parsed in multiple ways, and such as like if you have 1 plus 2 times 3, well, you could either interpret it as 1 plus the result of 2 times 3, or you could interpret it as 1 plus 2 first, and then that result times 3. There's could potentially be multiple parse trees, and nearly will actually give you both parsers in that case. It's usually bad to have ambiguous parsers, so that's not something you want in general. Even though it's possible, I discourage it. So I'm just gonna try to detect that if that happens and try to rectify it by changing the grammar. So here I'm actually gonna say if parser.results length is greater than 1, I'm gonna give a warning. The parse tree generates multiple results, and I'll log the results. Well, in either case, we're logging the results, I guess. Okay. Yeah, I'll log all the results, and otherwise I'm only gonna log the first result. How about that? I like that. Okay, so now it's only gonna log the first result because the tree is not ambiguous, or the parser so far we haven't seen it to be ambiguous. So basically this tree, this is the AST tree. Okay, this guy is the AST tree. AST tree. Well, AST already has the word tree in it, and we're gonna build on this. So the things. So we have done making grammar in nearly now and a parser, and now we're gonna add a couple more features. I think I said that I wanted to be able to have a function call, yeah, in addition to variable assignment, right? So let's do that. Let's make the grammar allow to support function call. So I'm gonna say function call. What does a function call look like? Well, there's an identifier, the name of the function, and then we'll allow some optional white space here, and then we'll have a left paren, which I'm gonna write out the literal for it, and then I'm gonna say this is gonna be a parameter list actually. And then a close, and then a right paren. Okay. And what is a parameter list? Let's define. Before I do that, it's bothering me. I'm gonna. Oh, hi, Balaji, welcome. Okay, so let's see. I wanna allow the syntax to either be an assignment or a function call, right? So I'm gonna have something called a top level statement, or just a statement. And I'm just gonna say a statement is either an assignment, which I'm gonna use the ID to unpack it automatically, because whenever there's only one thing, usually whenever there's only one thing in the right hand side of your production rule, you should use the ID function to unpack it. So a statement is either an assignment or a function call. Okay, so and then we still need to allow any number of lines, so we'll do that next, but for now let's deal with this function call bit. So let me make a example for function call first. So example function call .x. So example function call might be something like print hello world. Okay, which we should, this should work once we get the parser going, because the Lexer already supports string literals. Okay, so that's what a function call is going to look like. So a function call starts with an identifier, optional white space. Let's also do optional white space here probably. And then now we need to answer the question, what is a parameter list? Okay, a parameter list is going to be a probably a value, like an expression, which is either a literal or an identifier at this point. So I'm gonna call it expression. I'm gonna define that as an expression is either an identifier or a literal. And again, I'm gonna use this ID thing to unpack the array. Again, whenever you're matching only one, your right hand side of the rule has only one thing, you usually want to do the ID thing. Okay, so an expression is either an identifier, which is a variable, or a literal, like a literal number 5 or something. So a parameter list can have just one expression, or it could be a expression and then a comma. Oh, not comma. I said we're not going to allow commas in this language, so it would be mandatory white space. Oh, white space, I didn't differentiate between mandatory white space and optional white space. Let me see how the Lexer works. Okay, I think, okay, so white space is actually some white space. So double underscore should be mandatory white space. I'm gonna write a line of comment here, actually. How do you write comments? Okay, I'm gonna call this mandatory white space. Hi, nasty mixture, welcome. And then I'm gonna call this optional white space. Optional white space is gonna either be null, I think. Either be null or or the mandatory white space. I believe that's how we can do it. And I'll call this optional white space. Is that how I did it in the past? I hope this is right. Okay, so this is optional white space, and this is mandatory white space. And I'm saying, because I don't want to even use commas in this programming language, I'm going to use mandatory white space to separate the parameters in the parameter list instead of a comma. And so I'm going to say, and then after this mandatory white space, you can have more parameter list. There's some nuance to this, which I can't remember, but I'm just gonna test it and see if it works. And if it doesn't work, we'll have to fix it. Okay, so this is a parameter list. Yeah, let's just try this. Actually, before I try it, I'm gonna write this just converter to convert these matches to an AST node. So this guy here, let me do it here first. So this guy only has one thing, so I'm gonna do ID, but this guy actually has the three things in this match array. It has see, three things, and I only care about that guy, and this guy is 0, and this guy is 1, right? So I'm gonna say I'm gonna get a data array, and I'm gonna return something of type. Actually, this is not even gonna be an AST node. I'm just gonna return an array, I believe. An array of whatever the things inside it are, which can either be identifiers or literals, okay? And the data, this guy is gonna be one individual thing. So data 0, this is data index 0. This is data index 2, but that's gonna give me another, that's supposed to give me another array. So that makes this one wrong, actually. I have to go back and fix that. So data index 2 is supposed to give me an array. I want to spread it onto this array to make a larger array with this additional item. Which means this one I actually want to do it like this. Do it like this. Start off with an array so that next time it returns from here, this is actually an array and not an individual item, and it can be spread onto this array. And then now here, the function call. For this function call, I'm gonna take, so this gonna have a type. I'm gonna do a return statement. Okay, this guy is gonna have a type of function call. And what does a function call has? Well, it's the function name. I'm gonna call it fun name. The function name is gonna be at index 0 because that's very first thing. So data at 0, and this will be an identifier token directly from the Lexer. And then we're gonna have the parameter list. I'm just gonna call that parameters. And where does that come from? Well, index 0, 1, 2, 3, 4. So it's index 4 is where the parameters are coming from. And there we have our function call. So let's try this and see if this guy works. I need to run gen parser. That didn't work. I think there's a syntax error in my grammar, so I'm gonna hunt down to see where that is. It doesn't like this syntax on line 7. Oh, because I needed a vertical bar. So this should look like this. Hi web scrap. Welcome, welcome. Okay. So let me try to compile this again. Okay, it compiled. Now I'm gonna try to have the parse script parse this file now. See if that works. This is called example function call. That seems to have worked. We get an AST node which has the type of function call, and it's got a fun name. It's the function name, which is an identifier. It has the value of print. So we're calling the print function basically is what this means, and it's got parameters. The parameter, there's one parameter in the parameters array, and it is a string literal hello world. That makes sense. I'm gonna try multiple parameters. So again, in this language, I decided to not have commas because I wanted to be just slightly odd. So you just separate the parameters with spaces. It's sort of like Lisp in a way, because that's how Lisp does it. And that seems to work. That can do, now we have parameters string, literal, number, and then another number. We can even have identifiers. So say X, Y, Z. That should still work. Yep, those are identifiers now. We got X, Y, and Z are identifiers, and a number before that, and a string literal before that. So that's cool. What about if it has no parameters? Then what happens? Then it doesn't work. My grammar doesn't support a function call with no parameters, so maybe I should fix that. So one way I could fix that is just add another clause here, not here, but here, to say, well, it's okay you don't have a parameter list, that's fine. Another way I could fix it is by allowing the parameter list to be empty. Let me think about it. Maybe I allowed this to be empty. Yeah. So I'm gonna say, and in nearly JS, the way to be empty is null. To match something empty is null. And I'm gonna say if you match null, then you should return an empty array because yeah. Does this work? I'm gonna just try this. Again, I feel like there's some nuance to this one that it does work. I'm just slightly worried that I might have like an ambiguous grammar or something, but I'll just test it. So print 1, 2, 3. This seems to be okay. So we got a AST now. So I'm gonna wrap it up, but before we wrap up, I'm just gonna make it slightly nicer so that this print script will generate an AST file that is nicely formatted, okay? So perhaps what I do is I'm gonna take whatever the file name is and rename it to .ast. So I'm gonna do it like this. AST file name is equal to, oh, I need the path module for this. So path dot base name of the file name plus .ast, and that's the AST file name. I'm gonna say fs.write file, write to the AST file name, and then the thing I want to write is json.stringify the AST with this level of indentation. What's AST? That. the parser that results index 0, that's our AST. That's the thing we've been printing all along. And after this, customarily I write an output that says I wrote this file. All right, let me test this. Yeah, so we wrote this .ast file. Oh, I kind of wanna. This is actually okay, I think, having this X in here. So let's look at this AST file, and that's the AST for this program. That looks pretty good. Oh, there's one more thing I want to do, which is currently this parser doesn't support multi-lines, and that's kind of messed up. I think everything in this file should be supported. If multi-line worked. So I'm gonna add multi-line support, and then it can parse our example 1.x. Okay. So how do you do multi-line? First, let me prove that it doesn't work for this file. Example 1.x. Yeah, it doesn't work. It saw a new line token. It didn't know what to do about it. So what I'm going to do is say the top level of the program is actually not a single statement, because right now the top level is a single statement, which will only allow the file to have a single statement in it. The top level of the parse tree should be a number of statements, any number of statements. And we're gonna do this repeating trick again that we did over here. So perhaps do it like 3 separate statements like this, or maybe allow for an empty file. Yeah, let's do it like that. So null, if we have it's an empty file, then our statement is empty array. But if we had one statement, then the thing that represents the program should be an array with that statement in it, which is going to be data index 0, because it's referring to the stuff in here. And then, but it could also be a statement, and then a new line, and then more statements. Okay. In which case, we're gonna do it. We're gonna return a new array. We're gonna spread the rest of the statements on there, while appending this new statement. Well, I can't call it just statements. I'm gonna have to call it index 0, 1, and 2. So this is 2, and then this is index 0 names this statement. Okay, so I think this makes multi-lines work. Let's see. I need to generate a parser, and let's parse this. And it generated the AST file. Let me look at the AST file. Yeah, it has an array of statements now. The first statement is an assignment that assigns the number 4 to identifier n. Let me do a side by side. That looks right. Oops. Okay. There we go. So yeah, we're doing a side by side. So that's the first statement. First statement was this one. Second statement is another assignment, assigns the number 5 to identifier m. That looks right. And the third one is another assignment, assigns the string hello world to the identifier o. So that looks correct. The next one is a function call. It's calling the function print with identifier print, and its parameters are the identifier n followed by the identifier m. So that looks correct. another function call, and again calling the print function with the parameter O, and then another and a couple more function calls after that. So everything looks like it's in order. I think what I'm gonna do is post this on GitHub. Actually, perhaps I'll do that right now on stream, so that for those of you who are following or watching, you can access the code. And play with it. I'm gonna git ignore the node modules folder really quick, and then check this into Git. There it is. Okay, so I'm gonna make a new repository, call it xlang, a demo programming language. I'll say code streamed live. Create a repository. I'm gonna push this code out here. So this is what now? Oh, I didn't make a first check-in. First check-in. You're welcome, I said. Okay, now I made a first check-in, and now I can push this code. And oh, I didn't write a README file, so but I'll probably do that after the stream. So this repo is there for those of you who are interested in getting this code, or comparing your programming language to mine, or just using mine as a reference. I'm planning to do this as an ongoing series, so adding more features of the language in the upcoming weeks. So keep an eye out for that. For now, tentatively, I'm planning to do it every Friday morning. So if you're interested in watching this, then yeah, be there next Friday. Okay, I'm gonna end the stream. Bye everyone. Thank you for attending.